Alrighty, so just talking through the answers to your warm-up. Remember, when you add or subtract fractions, you always have to have a common denominator. I saw some of you fill in that blank without me even filling it in. Nice job. Multiplication and division, no common denominator needed. So you're going to see in the first two problems, I did get a common denominator because I was adding and subtracting the fraction. So your answer to the first problem is 13/12. You can leave it like that. Think about why I would have you leave it like that. Remember, we're studying the ER rule. So this is an exponent on the top here. This is going to be your root. It's not as helpful if you turn that into a mixed number. Like, I'm going to guess some of you might even have 1 and 1/12. But in this chapter, you actually want to leave it as the improper fraction because you need a top and you need a bottom because, you know, if you did okay on your quiz just a few moments ago, you know, that top number has meaning, that bottom number has meaning. So you need that. Same thing, well, not really the same thing, but 1/10 would be like the 10th root of something, right? If that were an exponent. So that blue problem there, yeah, your answer is 1/10. Remember, some of you always worried about time, the time it takes you to finish a test. So it could come down to, you know, questions like 3/5 times a ninth or 2/7 divided by 1/49. You know, I encourage you to minimize the number of steps you take. So for instance, 3/5 times 1/9, I would cross cancel the 3 and the 9. Cross cancel your factors of 3. You know, 3 goes into 3 one time, 3 goes into 9 3 times. So you're just doing 1/15. It's a lot faster than doing 3 times 1, which is 3, 5 times 9 is 45, and then you have to reduce 3 out of 45, especially if you don't have a calculator, right? Same thing with that last problem. I think a lot of you in the room did that keep, change, flip. Keep, change, flip. You keep 2/7, you change division to multiplication, and you flip the divisor, multiply by the reciprocal of the divisor. And then, so that gives you the setup of 2/7 times 49/1. And then you see that I cross-canceled again. That particular skill of cross-canceling comes in big in Chapter 8. It's actually a requirement because we do this stuff with polynomials. So just a little heads up. If you're not accustomed to cross-canceling to reduce ahead of time, you're going to want to adapt that skill because it becomes essential in Chapter 8. But if you have questions about it or you need me to sit down and walk you through it a little bit, I'm happy to do that. Okay. All right. Giddy up, kids. Today's lesson is actually pretty straightforward. We're going to do properties of exponents. You've done this lesson before. It's the exact same lesson we did in the beginning of Chapter 5. If you look around the room, I recycled an activity for another class I teach that around the room with properties of exponents. You've done the properties of exponents before. This chart's not different. I promised you that I was going to take it up a notch in Chapter 6. The notch we take it up to, do you see your exponents? We're going to do the same properties, but your exponents this time around are fractions. So that's just, you know, I'm not changing any of the rules we play by. It's just a little tougher because we have fractions to work with. So, taking a look at our product rule, that was our rule that said if we multiply like bases together, you're allowed to add your exponents. So in this case, you have 4 to the 1/2 times 4 to the 3/2. That's 1/2 and 3/2, 4/2. That's 4 squared, which is 16. So we add the exponents together. You're allowed to add these guys. So I added them. Next up, we have this sort of distributive property for exponents. I really shouldn't call it that. But it's basically what you're going to see whenever you have parentheses in your problem. But these parentheses never have a plus and they never have a minus sign in them. If we have plus or minus, this rule doesn't apply. We actually FOIL, do that repeated multiplication out. But in this case, it's just saying we're allowed to multiply our exponents together. So a couple of examples here. see how you have 2, and then that's raised to the 5/2 power, and then we're going to square it. All I have to do is multiply 2 times 5/2. 2 times 5/2. 2's cross cancel. We get 2 to the 5th, and that's 32. Notice we're writing our answer in simplest form. Can't get simpler than 32, right? Can't reduce it. It's going to root it. Next problem here, 16 times 4. See how that's a times? So what I'm trying to tell you is that as long as this is not a plus or a minus, I could take this 1/2 and give it to the 16. I could take the 1/2 and give it to the 4. So this is going to become 16 to the 1/2 power times 4 to the 1/2 power. Remember, numbers have exponents. So essentially, I took 1/2 times 1 for both factors. And then I think everybody in the room remembers pretty well, at least I glanced down at the quizzes you just took. 16 to the 1/2, that's the same as the square root of 16. Square root of 4 is 4 to the 1/2. So what we're doing there is 4 times 2. The answer to that problem is 8. I was just using this example to demonstrate that I'm allowed to distribute that exponent in as long as there's just a product there. But you could have done 16 times 4 to get 64, and then the square root of 64 is 8. I'm just demonstrating this particular power property. And I could distribute that 1/3 in. 27 and 8 have exponents. So this guy's now going to be 27 to the 1/3 over 8 to the 1/3. And then we're going to have the cube root of 27, that's 3. Cube root 8 is 2. So 3/2 is your answer there. All right. The next property we have was the property that allowed us to subtract our exponents. So we're allowed to add our exponents if we multiply like bases. We're allowed to multiply our exponents as long as there's no plus or minus in the parentheses. And we're allowed to subtract our exponents when we have a quotient of like bases. It's our quotient rule. So here, I have 3 to the 5/2 over 3 to the 1/2. I'm allowed to just subtract those exponents. It's the same rule as in chapter 5. So this is going to be 3 to the 4/2, which is 3 squared, which is 9. There's a couple of problems here, and I'm just noticing this today, which is unfortunate. There's supposed to be a couple negatives hanging out. This is an example of the negative exponent rule, right? Difficult to demonstrate if you don't have a negative exponent there. So I just went ahead and made that negative. I grabbed a white utility from my stylus, and then I just made a little white out there. So yeah, we're doing 25 to the negative 1/2 power. Remember, negative exponents act like bad puppies, right? We can't have a negative exponent in this chapter either. So the rule is, bad puppies, yeah, just kind of, they live at my house anyways, we kind of move her to the basement and chill out for a second. Her little crate, she likes it in there, little den animal. And then we got 1 over the square root of 25. And then the square root of 25, that's just 5. So you can't have negative exponents in a final answer. Keep in mind, for the sake of this course, if this problem read negative 1/3, you'd have the cube root on the bottom. You can just leave that there. You don't have to rationalize that. If it were the square root of 7, though, on the bottom, you would have to rationalize that. So a little heads up on that. Okie dokes. And the last rule of the day, we still have our 0 exponent rule. And just to review, it comes from when we get 1, right? If you have 3 to the 1/2 over 3 to the 1/2, you can look at it, that's 1. But using your properties of exponents to justify that, you know, we're taking a half minus a half. Well, that's 3 to the 0th power. And that's why we get 1. So we still have the 0 exponent rule coming at us. So that was kind of a quick rundown on our properties of exponents. The only difference in this chapter is that the exponents are fractions, but the rules are the same. You guys crushed them the first time around. I do think that's something they did really well at the middle school. I think that's because it's a big keystone topic. But that I think you guys are going to do quite well with this. Keystones. You didn't like those, huh?
No, it was just like we barely did exponents in Algebra 1, but that was our COVID year, so
Oh.
it was just weird. And then, like,
You cool with it now, though?
Yeah, then like Mrs. Grunwald retaught it all to us in geometry.
Oh, that's right, because she had a... is that the year she had the baby, too?
Yeah, I think so, the year before, but not
Yeah, I remember. Okay. So, now you get to practice, now that we've gone through the rules a little bit. What's interesting to note, I'm going to show you the answers here in a minute, and this is the only thing I needed to teach you today, so we'll come back and we'll do the rest of the lesson on Monday. You'll be able to do again about the top half of 6-2 practice A. It's not due until Tuesday, so you can take some time over the weekend to start it and then, you know, finish it up Monday night. But this will help us wrap up day 1 of the lesson. Notice, I'm just going to read the directions together so we have an idea of what to expect. It says, use the properties of rational exponents to simplify the expressions. You can use your special numbers to know paper. I'd like you to try to not touch a calculator. Try to not touch a calculator for these. If nothing else, just to get the fraction practice. That's going to be important for Chapter 8. Because your calculator won't add the big rational expressions that you have to add in Chapter 8. So I'd rather just go through this with numbers rather than, all of a sudden you have like a million polynomials to do this with and you're like, I don't know how to add fractions. So I'd rather sort that out now than later. Small problem now, big problem later. So just take a minute to do that. I will let you know when I flip to the answers, because I always work them out before you get here. You're going to see I write the answer in 2 ways. I need us to start to transfer the idea that, yeah, we're getting fractional exponents. So you can write your answer just with a fractional exponent. But we want to be able to turn that also into a radical, right? Which kind of moves us into Monday's lesson a little bit. So when you see my answer, you're going to see I circled 2 different answers. I left the fractional exponent and I turned it back into a radical. So if you want to go that extra step to start practicing that, you're going to see it on my slide. So just a little heads up on that. But yeah, if you want to go ahead and practice the rules, I'll come around and help you out. So there's your first answer. It's looking really good as I walk around. Notice I have 2 answers here, right? This affords me a small opportunity. As I walk around, everybody was adding their exponents. You're doing a fantastic job. If the homework or any directions I give you on a test or a quiz, if it just says simplify or evaluate, you get a choice into how you write your answer. So if it doesn't say leave it as a simplified radical, you don't have to do this step. If the directions say write your answer as a simplified radical, then you have to do this step. So let's talk about it. We've actually talked about this before. I said you don't have to worry about it until later. It was this idea of reducing the index, like you have it like written in a warm-up. It's earlier in the chapter. We talked about it just for a second, and here's where it actually becomes official. All right, so everybody in the room as I walk around, you were adding your exponents. A half is 2/4 plus 3/4. That's 5/4. So that looked good. 9 to the 5/4, legit, super proud of you. That's progress, okay? The next thing we would do is our ER rule, right? So this is the same as 9 to the 5th, but then we have to 4th root it. So that's how I got this step. I then actually do the division that's indicated. I ask myself, how many times does 4 go into 5? It's once. The 4th root of 9 can actually be simplified because 9 is a perfect square. So since 9 is a perfect square, you have 3 squared hanging out in there, and then you're 4th rooting it. You can't leave the 4th root of 3 squared because 2/4, doing that ER rule, actually reduces. 2/4 is 1/2. So you have to reduce the index on that. To write it as a simplified radical, it's 9 square roots of 3. I know some of you are sitting there, I wouldn't know to do that. Okay, that's why I'm showing it to you, right? So if you want to come back and study this one before you take a test or a quiz, the skill, it doesn't happen often, but it's there. The skill is to reduce the index. That is what I did there. And now you have 2 cases of it in your notes. So just a little heads up on that. It does happen periodically. Again, you only have to worry about it if it says leave your answer as a simplified radical. So take a second, read it over. And just a couple more here. Part C, you were subtracting your exponents. 5, 6 minus 2, 6, that's 3, 6. 3, 6 is a half. 3 to the 1/2 is a fine final answer, but if it says leave it as a simplified radical, that's just the square root of 3. And then the last one. Whoops, almost deleted the whole slide. Hold on. There we go. Okay, this one. I'll walk you through it a little bit. You have options for how you do these problems. I just actually took some time to take the 2/3 out because I noticed it was a 2/3 on the top and bottom. So in the first step, when I did this problem, I pulled the 2/3 out like it was a factor. Remember, these properties are two-way streets. You can distribute an exponent into the parentheses, but you can also pull it out, you know? Pretty cool. So I just did the reverse of our power rule there. And then I was like, 16/4, I know what that is. 16 divided by 4, that's easy, that's 4. And then I had 4 to the 2/3, because there's still that 2/3 there. So 4 to the 2/3, I could just multiply then 4 times 2/3, that's 8/3. And that's also a great answer, you know, it's reduced. What's up, Kara?
Would we have to have a common denominator?
Where?
With the 4.
Which 4, honey?
The exponent.
Right here?
Yeah, 2/3 times the exponent of 4/1. So wouldn't we have to have the same denominator?
We're multiplying them.
Okay.
You only need a common denominator. Remember from the fill in the blank at the beginning of the warm-up? Yeah. When you add or subtract fractions, you need a common denominator. Good asking, though. That's the kind of question I need. Nice job. Now, Kara, just a heads up. Like, you wouldn't be wrong if you got a common denominator, because a common denominator preserves the value of the fraction.
Yeah.
You would still get the same number, but you'd have a lot of reducing along the way to get there. You know what I mean?
Yeah.
So you're inserting factors that are just going to fall off later on anyway.
Yeah.
You would see if you did that, you should still get the same answer. It's just you're making some work for yourself that doesn't need to be there.
Yeah, I got 4 to the 8th exponent and then big number. So I don't think it.
Okay, I can look at it if you need me to too. But yeah, this ends up being 4 to the 8/3. If it says write your answer as a simplified radical, you got to do your ER rule and then simplify, right? So again, like this is like Maddie and I's conversation from earlier. Ask yourself how many times does 3 go into 8? It's twice. There's 2 left over. And now you're like looking at a problem that might have been on your quiz that you just got back today. If you got 4 squared, that's 16, and then you got to simplify the cube root of 16. That breaks down into 8 times 2. Cube root of 8 is 2. 2 16s is 32. So 32 cube roots of 2 is what you get for your simplified radical answer. So if it doesn't say how you have to write an answer, you can leave it like this. If it says write it as a simplified radical, you've got to go a little further and use your ER rule from the last section. Okay, that's the trick. And then simplify. Wow, perfect timing. Yeah, so give that homework a try tonight. It's not due till Tuesday. We'll talk about it a little later. Have a lovely weekend.